Welcome everybody. Today we want to look at the principles of nutrition, but basically we want to understand the important nutrients that our bodies use to function properly. We also like to describe the importance of the various nutrients in the body and understand the digestion, absorption, metabolism, and the transportation of these nutrients in the body. Particularly, we are going to look at the classification of these nutrients, the carbohydrates, the proteins, the fats, the vitamins, and the minerals. When we look at food and health, we see a great interlinkage. Food and health are intimately connected, and dietary advice is always an essential part of healthcare throughout the world. We have come to embrace the importance of nutrition in our lives, the importance of food, because we know that without food, the body cannot function. Without food, man cannot live. So the links between diet and disease have long been recognized, and food has been used as medicine for thousands of years. One scientist says that if you do not eat food as your medicine, you will start to eat medicine as your food. When you fall sick, you'll have to take medicine always to feel better. But it's better to always prevent disease by eating healthy and exercising, remaining healthy, than to wait to get sick so that you seek treatment. It wasn't until the 20th century that scientists began to put together a profile of nutrients, including carbohydrates, proteins, fats, vitamins, and minerals that are essential to health. So what are nutrients? The word nutrients is derived from the word nutrition. And we previously talked about nutrition as healthy eating, consumption of the required nutrients for the proper function of our bodies. So nutrients are the nourishing chemical substances extracted from the food one eats as it passes through the digestive system. The nutrients in nature exist as either organic or inorganic compounds. The organic nutrients include all those nutrients that bear a carbon atom, and the rest of all the nutrients that do not bear a carbon atom exist as inorganic compounds. The digestion of food and its elimination from the body are the foundations of good health. When we eat any kind of food substance, it goes through the process of digestion, as we looked at it previously. And once it's digested, then the waste products are released out of the body through the anus as feces. So that whole fundamental process, from ingestion from the mouth to digestion to egestion out of the body, these are the foundations of good health. Once you take in a food product and it's not able to be digested, it's going to pile inside your system and it will become toxic and cause you ill health. But once you eat any food substance, you're supposed to digest it properly, then you extract the nutrients out of it, and then the excess can be excreted. Nutrients are very essential for cell growth, maintenance, and repair. And from our fundamental science, we know that proteins are the ones that basically help in the maintenance and repair of body tissues and also in cell growth. So nutrients provide energy to enable the body function efficiently and to ward off infections and diseases. The main nutrients are carbohydrates, fats, proteins, vitamins, and minerals. However, fiber and water are also very essential. No nutrient works alone. Each depends on the other to be most effective. When we eat a meal, nutrients are released from food through digestion. And this process begins in the mouth by action of chewing and the chemical activity of saliva. And then further digestion occurs as food travels through the stomach and the small intestines. And various enzymes are released to enable this process to go on efficiently. Nutrients are absorbed from the inside of the small intestine into the bloodstream and is carried to the sites in the body where they are needed. When the brain lacks glucose, once you eat carbohydrate-rich foods, the glucose is extracted and then it goes into the bloodstream and is transported towards your brain to maintain the function of the body. So the waste products of digestion are processed by the liver and the kidneys, and they are eliminated from the body through our urine and the feces. These parts of the foods that are not absorbed continue to move down the intestinal tract, and they are eliminated from the body. Nutrients can be classified in various ways. One of the ways is as essential or non-essential nutrients. Non-essential nutrients are manufactured in the body and they do not need to be obtained from food. For example, cholesterol, which is a fat-like substance that is present in all animal cells. While the essential nutrients must be obtained from food sources because the body either does not produce them or produces them in amounts that are too small to maintain growth and health. Any individual needs varying amounts of each essential nutrient, depending upon such factors as gender and age. Everybody requires a different amount of nutrients. And specific health conditions, for example, pregnancy, breastfeeding, illness, or drug use, make unusual demands on the body and increase its need for nutrients. So the dietary guidelines, which take many of these factors into account, provide general guidance in meeting the daily nutritional needs, as we previously looked at the recommended dietary intake levels for various age groups and for various individuals. Aside from essential and non-essential nutrients, we can also classify nutrients as either macro or micronutrients. Macro means large. So macronutrients are large molecules, for example, the carbohydrates, proteins, and the fats, while micro means small. So micronutrients are small molecules, for example, the vitamins and minerals, and they're also needed in the body in small amounts to maintain proper function. Carbohydrates are found in bread, in pasta, rice, potatoes, cassava, cereals, and pulses, and they mainly release energy slowly to provide the body's basic source of energy. Simple carbohydrates, for example, sugars, give instant energy and they do not have nutritional value. That is why we encourage our patients to limit the intake of simple sugars. So complex carbohydrates are found in also bread, pasta, rice, potatoes, and all the rest. And they also contain fiber, vitamins, and minerals in different proportions. Whole grain products are always more nutritious than the refined products because they're digested slowly and they provide sustained energy. But if you eat the refined grain products, they release energy very quickly. And this is not going to be very healthy for your body because it will cause accumulation of fats because every excess is stored as fat in the body and it becomes toxic. Proteins, on the other hand, are found in meat, poultry, fish, eggs, and also in plants, for example, nuts, pulses, and beans. They are essential for growth, maintenance, and repair of body tissues. Everybody needs around 2 to 3 servings of protein per day, but most people normally eat more protein than they need, which is then converted to fats in the liver. It takes 9 calories of protein to make 1 gram of fat. Fats are essential for us for good health. They insulate the body and cushion the vital organs from any harm. And they can also be converted into energy. They are used to build new cells and are also critical for normal brain development and nerve function. Fats are also very important in the absorption of some nutrients, for example, vitamins. The fat-soluble vitamins require fat for their absorption. Without the fat, they will not be absorbed, and there will be a lack in the body, and they will cause micronutrient deficiencies. So the micronutrients, such as the vitamins, are organic substances, and they include vitamin A, B, C, D, E, and K. And the B complex vitamins are very many. We have vitamin B1, vitamin B2, B3, vitamin B5, B6, vitamin B8, vitamin B9, vitamin B12. All those are essential vitamins in the body that will be further looked at. And the fat-soluble vitamins are A, D, E, and K. The water-soluble vitamins are the B-complex vitamins that I've mentioned already. So vitamins activate enzymes, which are the proteins that act as catalysts to speed up the biological reactions that take place in one's body. They have important functions in maintaining strong bonds and controlling hormonal activity. The body can make a certain amount of vitamins, for example, vitamin D and vitamin K, but one has to obtain all the other vitamins from the diet, and so they are very essential nutrients. You have to obtain them from the diet that you consume. Minerals are inorganic substances that originate from rocks and ores, and they find their way into the food chain through the soil. Plants grow out of the soil, and so they absorb these minerals and they grow with them. So once we consume the plant's products, we are able to obtain the minerals. And also when we consume the animals that take these plants, we are able to obtain the minerals. Calcium, magnesium, and phosphorus are one of the major constituents of bone, while sodium and potassium control your body's water balance. And then the remaining minerals are needed for various chemical processes to take place in the body. Nutrients for optimum health. According to various studies, it has been indicated and found out that not only are certain nutrients essential for life, maximizing one's intake of nutrients enables the body to function as efficiently as possible and improves health. And so we are going to look at some of these importances of the nutrients in the body. For example, boosting immunity and fighting infection. This is all done by the nutrients that we take in. Inadequate nutrition impairs the body's ability to keep its defenses in top working order. When you do not eat healthy, your immunity weakens. The immune system needs certain vitamins and minerals to produce specialized body cells that destroy specific invaders. For example, a lack of vitamins A, C, and E and B complex reduces immunity. Vitamin C is also very crucial for immune function. It has antiviral and antibacterial properties, and it is also a natural antihistamine. Antihistamines are used primarily to control symptoms of allergic reactions. There could be a food item that once you eat it, your body reacts and causes a rash. Those are allergic reactions. Your body reacts to this food item as if it were harmful. So once you have enough vitamin C, then you are able to produce enough antihistamines that are able to block these allergic reactions in the body. Essential fats also reduce inflammation and infection. Providing energy is one of the essential purpose of the nutrients we take in. We already said that the basic source of energy for our bodies is the carbohydrates. However, a host of nutrients are also required to turn the food into energy, including most of the B vitamins, vitamin C, iron, copper, and magnesium. Remember, we said that no nutrient functions alone. It needs the other nutrients to be efficient. So to release enough energy in the body, we need these nutrients to complement the carbohydrates. So they help to make hormones, which are responsible for nerve transmission and maximizing energy utilization. Weight control. Body weight has an effect on health, and every person has an optimal weight linked to their height, bone structure, and amount of muscle. So maintaining a healthy weight depends on one's ability to burn fats and break down glucose into energy. The B vitamins, the vitamin C, iron, and chromium are very essential for converting glucose into energy and transporting it to the cells. For people who are overweight, a low-fat and high-fiber diet may help them in weight loss. Reduce the amount of fat you eat, increase the amount of fiber so that you can have a sustained release of energy into the body. A healthy heart. Once we eat healthy, then we maintain a healthy heart. Heart diseases are caused mainly by blood clots, by hardening of the arteries to the heart, narrowing of the arteries caused by buildup of fatty deposits, and raised blood pressure. So certain vitamins and minerals have proven benefits for maintaining a healthy heart and blood vessels. Strong bones and powerful muscles. One always needs to have sufficient quantities of calcium, magnesium, and phosphorus to keep the bones strong and healthy. Vitamin D controls calcium uptake, and vitamin C makes collagen, which strengthens the connective tissue. Mental health. There are several nutritional factors that are known to influence mood and mental function. The brain needs glucose, which is the end product of carbohydrates metabolism, to function properly. Once you do not have enough glucose, then your brain is not going to function well. And that takes us to the issue of mental health. The body's ability to use glucose also depends on several vitamins and minerals, especially vitamin B3 and B6, manganese and zinc. Blood sugar levels that affect mood can be unbalanced by consuming too much of the wrong thing, such as caffeine, cigarettes, and alcohol. When you take a lot of these drugs, your brain becomes uncoordinated. It starts having improper balance, and this causes mental health issues. Retarding the aging process. This is another function of nutrients in the body. Research has indicated that the aging process is the result of the body's declining ability to repair the damage caused by free radicals. Remember, consumption of too much of anything will cause release of free radicals in the body. For example, if you consume a lot of sugars, it will cause a rapid release of free radicals. And these free radicals cause oxidative stress in the body, and then they lead to inflammation of the tissues. And this inflammation will quicken the aging process. But when you control every portion that you eat, and you take the recommended amounts of food, then you're able to reduce the aging process. Everybody wants to remain young. Nobody wants to grow old so quickly. So it's always very important to look at our diet and be critical of what we take in. Increasing one's intake of antioxidants, which neutralize the free radicals, helps one to look and feel better as she gets older. For example, vitamin C. That's why we as nutritionists encourage that people consume a lot of fruits and vegetables, because these contain a lot of antioxidants that reduce the oxidative stress caused to the body by the free radicals. Inorganic and organic nutrients. The presence or absence of carbon is what differentiates organic nutrients from inorganic nutrients. Organic nutrients owe their complexity to the carbon atom. The ability of carbons to use covalent bonds to build up long chains of atoms accounts for the unique variety and complexity of organic molecules. Organic molecules such as carbohydrates, lipids, proteins, and vitamins have carbon in their structure, and this is what makes them organic. There are only two nutrients that are non-organic because they do not have the carbon atom within them. That is water and the minerals. Water exists as H2O, hydrogen and oxygen. There is no carbon in there. And the minerals, you always find them potassium labeled as K, calcium, Ca, magnesium, Mg. There is nowhere there is a carbon. So that is what makes them inorganic. Carbohydrates, we said, are the main source of energy, and they provide 4 calories of energy per gram. And they are macronutrients, which are the most abundant in nature. They are produced by green plants and by bacteria using the process known as photosynthesis. And we basically obtain them from the plant foods that we consume. The elements that are present in a carbohydrate are carbon, hydrogen, and oxygen. The smallest carbohydrate unit has a formula of CH2O in brackets N. The N signifies the total number of carbon, hydrogen, and oxygen atoms varies from one carbohydrate to another. Yes. This N will be dependent on the total number of carbons, hydrogen, and oxygen that are obtained in this particular carbohydrate. Plants act as the primary source of all carbohydrates required by humans, as we said that it is through the process of photosynthesis that only occurs in plants that carbohydrates are produced. How do we classify carbohydrates? Carbohydrates can be classified as monosaccharides, disaccharides, oligosaccharides, and polysaccharides. Monosaccharides. Mono means one. Monosaccharides are also called simple sugars, and they are the building blocks of the more complex carbohydrates. When two of the monosaccharides combine, they form disaccharides or a double sugar. Monosaccharides share the same formula, C6H12O6, but they differ in their molecular structure. And this brings in the concept of isomers that you looked at in chemistry. This means that two or more compounds have the same formula, but have different arrangement of atoms in the molecule, and they also have different properties. Although 12 hexose, that are 6 carbons, and 6 pentose, those are 5 carbons isomers, can be found in nature, only 3 hexoses, that is glucose, galactose, and fructose, can be absorbed by humans. The edible hexoses differ in chemical behavior, taste, sweetness, and dietary source. These differences result from the slight but significant differences in their chemical structures because they are isomers. They have the same formula, but they have different chemical structures and they have different properties. For example, glucose and galactose contain an aldehyde group on carbon 1 compared with the ketone group that is on carbon 2 of fructose. Because the hydroxyl group on carbon 1 can reduce, that is, donate hydrogen to metals, for example, copper and iron, glucose and galactose are called reducing sugars. This is due to their reducing properties. They are able to release hydrogen to other metals. The active ketone at carbon 2 in fructose also reacts with the hydroxyl carbon at C5 to form a 5-membered rather than a 6-membered ring formed by the aldoses, glucose and fructose. The active aldehyde and ketone carbons perform 2 special functions. 1, they can react with the hydroxyl group of carbon 5 to form a ring structure. When the ring is formed, the active carbons can link to other sugars by forming a glycosidic linkage with another hydroxyl group. Glucose. We've been talking about glucose. We now want to understand in detail what is glucose and where is it found and how can we take it in. Glucose is mainly found in honey and the juices of many fruits. The alternate name is grape sugar. It was named grape sugar because grapes contain glucose. Glucose is a normal constituent of blood of animals, and it is a white crystalline solid that is less sweet than the ordinary table sugar that we eat. Solutions of glucose rotate plain polarized light to the right, and so they are called dextrose sugar. Dexter means right. So glucose rotates the plane of polarized light to the right. It is formed by the hydrolysis of many carbohydrates, including sucrose, maltose, cellulose, starch, and glycogen. Glucose is made industrially by the hydrolysis of starch under the influence of dilute acids. It is the most widely distributed sugar in nature, although it is seldom consumed in its monosaccharide form. In the polymer form, glucose is present as starch and cellulose and is found in all the edible disaccharides. So what are the uses of glucose? Glucose can be used as a sweetening agent in the food processing industries. There are a lot of packaged food items that we consume that are so sweet. There is an element of glucose that is added in them to make the sweetness come out. It can also be used in treating dehydration and for intravenous feeding. In the context of malnutrition, we shall find some children are dehydrated. So to make them return back to normal, we can give them solutions of glucose. And also for patients that are ill and they are not able to consume any kind of food item, we give them a dose of glucose. Glucose can also be used in tanning, in dye baths, in making tableted products. It is also useful in special high energy diets. And glucose is only half as sweet as sucrose, so more may be used to give the same sweetness. Absorption of glucose. Glucose is absorbed into the bloodstream through the intestinal wall. Some of the glucose goes straight to work in our brain cells and the red blood cells, while the rest makes its way to the liver and muscles, where it is stored as glycogen, as animal starch. And also it can go to fat cells, where it is stored as fat. Glycogen is the body's auxiliary energy source, tapped and converted back into glucose when we need more energy. Whenever the body is in deficit, it will go and extract from the glycogen stores and form glucose. There are two hormones that control this process. We have insulin and glucagon, and we shall look further into them in the subsequent lectures. Although stored fat can also serve as a backup source of energy, it is never converted into glucose. Fructose and galactose, other sugar products resulting from the breakdown of carbohydrates, go straight to the liver where they are converted into glucose. Fructose, also known as levulose or fruit sugar. It's a monosaccharide that occurs with glucose in sweet fruits and fruit juices. Fructose is found in fruits. As you can hear its name, fructose, fruits. It is derived from fruits and is present in the invert sugar, a syrup that is made from sucrose and is used extensively in the food industry. It is formed along with glucose in the splitting of sucrose and is produced in the hydrolysis of various carbohydrates. In honey, glucose crystallizes out of the honey on standing at room temperature, leaving an uncrystallized layer of dissolved fructose. It is levorotatory. Lever means to the left. So it means that solutions of fructose rotate the plane of polarized light to the left. Fructose is fermented by yeast to yield ethyl alcohol and carbon dioxide. It is the sweetest of all monosaccharides, although its sweetness also varies. If it is dissolved in liquid, the sweetness rapidly declines, possibly because the dissolved fructose is free to assume less sweet configurations. Fructose makes up about 3% of the dry weight in vegetable and about 4% in honey. As fruits ripen, they become sweeter because the sucrose it contains is enzymatically cleaved to glucose and fructose, and that explains the sweetness of fruits once ripe. Galactose. This sugar is rarely free in nature. Most dietary galactose is produced from lactose, milk sugar, by hydrolysis during the digestive process. Disaccharides. We've been looking at monosaccharides. We've seen the examples of the monosaccharides. Galactose, fructose, glucose, all those were monosaccharides. Disaccharides. When two simple sugars combine, a disaccharide sugar is formed. The process occurs through condensation involving the loss of sugar. When something condenses, it releases water. So that process of water loss is the one that causes the formation of a disaccharide. A single molecule of water is removed from a pair of a monosaccharide molecule. And as a result, a covalent bond that results in the formation of glycosidic link is established, joining the two monosaccharide molecules. The linkage is formed between the active aldehyde or ketone carbon and any hydroxyl on any other sugar. This gives rise to a disaccharide with a general formula C12H22O11. Remember, it is a double sugar. Two monosaccharides combine to form a disaccharide, and a water molecule is lost. In case of two glucose molecules, the bond will be between position 1 in one of the molecules and position 4 in the other molecule, giving a 1,4 linked disaccharide. The disaccharide form depends on the monosaccharides that enter into its composition. Random linkage between hydroxyl groups of different sugars creates a bewildering variety of disaccharides configurations in nature. However, human absorptive capacity for carbohydrates is limited. So, despite the enormous variety of possible configurations in the food supply chain, humans utilize only a few disaccharides. Amylase enzyme that is secreted by the salivary glands and the pancreas cleaves only the alpha bond between two glucose molecules. And the enzymes in the brush border of the intestinal mucosal cells hydrolyze only these following. Sucrose hydrolyzes the alpha bond between glucose carbon 1 and fructose carbon 2, while Maltase enzyme hydrolyzes the alpha bond between glucose C1 and glucose C4. Isomaltase hydrolyzes the alpha bond between glucose C1 and glucose C6. Lactase hydrolyzes the beta bond between galactose C1 and glucose C4. So carbohydrates containing any other configurations are classified as dietary fiber. Sucrose, table sugar or cane sugar. Sucrose is commonly used at home. This is the sugar that you always take at home. It's extracted commercially from sugar beet or sugar cane and is formed by glucose and fructose linked together by their active carbons. Dietary sucrose can be hydrolyzed to glucose and fructose molecules, monomers. It dilutes acid or in the presence of the enzyme sucrase or invertase. This is the process of formation of sugar. A glucose molecule combines with the fructose molecule and releases a water molecule, and then it forms sucrose. A molecule of one kind of monosaccharide can combine with one or two molecules of the same monosaccharide or with other monosaccharides to form more complex disaccharides and trisaccharide sugars. Lactose. This is a disaccharide of glucose and galactose that is formed naturally only in milk and milk products. It accounts for 7.5% and 4.5% of the composition of human and cow's milk, respectively. It is less soluble than the other disaccharides and is only about 1/6 as sweet as glucose. It is hydrolyzed by lactase in the intestinal cells. Lactose intolerance. In children, lactose is hydrolyzed readily by the enzyme lactase. However, many people lose the ability to produce this lactase enzyme in adulthood, and this causes a condition known as lactose intolerance. This lactose intolerance is expressed late in the development of the intestinal cell toward the end of its migration to the tip of the intestinal villi. And that's the reason why it is often the first enzyme that is lost in the intestinal diseases. And the person develops lactose intolerance. And it is characterized by accumulation of gas in the body, bloating. Maltose. Maltose is a disaccharide sugar formed by action of the enzyme diastase on starch. It's seldom found naturally in the supply chain as a disaccharide, but is consumed in a number of food products. It is soluble in water and slightly soluble in alcohol and crystallizes in fine needles. Maltose is dextrorotatory. It rotates the plane of polarized light to the right, and upon hydrolysis, it yields a single product, glucose. Mainly, maltose is a combination of two glucose molecules. It is an easily digested sugar. Maltose is used in preparing infant food and in beverages such as malted milk. It is fermented by yeast and is important in the making of beer. The germinating seed produces diastase, an enzyme that hydrolyzes starch to maltose for use by the new plant. Thus, sprouted grains contain maltose. Maltose is often found in commercial products marketed as sucrose-free, even though maltose and sucrose have the same caloric value. Oligosaccharides are low molecular weight polymers containing 3 to 20 sugar molecules. And because they are small, they are readily water-soluble and often quite sweet. They are found in plant seeds, mainly legumes such as beans and peas, and cannot be broken down by endogenous enzymes. The non-digestible oligosaccharides are resistant to stomach acid and the action of amylase and the intestinal hydrolytic enzymes. They go further into the large intestines intact and can then be fermented by indigenous bacteria. Fermentation by gut bacteria is accompanied by complaints of gas and bloating. Raffinose is found in sugar beets. It is a trisaccharide made from glucose, fructose, and glucose. That is the combination of 3 monosaccharides: galactose, glucose, and fructose. Then stracciose is composed of 2 galactoses, 1 glucose and 1 fructose, and is found in vegetables and legumes. Fructo-oligosaccharides. These are naturally occurring polymers of fructose, usually attached to an initial glucose molecule. Sometimes they are commonly referred to as fructans. Fructo-oligosaccharides are totally resistant to digestion in the upper GIT and utilized almost entirely by bifidobacteria in the colon through the process of fermentation. When ingested chronically, they have been reported to enhance intestinal floral growth and relieve constipation. Shorter fructans predominate in cereals, and other sources are onions, garlic, and asparagus. The hydrolysis of fructans in the stomach and the small intestines is negligible, and any trisaccharides absorbed directly are usually excreted in the urine. The major part of fructans reaches the large intestine where it is fermented. Lastly, we'd like to talk about sugar alcohols. Sugar alcohols are present in nature and are sometimes prepared commercially. Sorbitol is one of the examples and is found naturally in some fruits such as cherries, but is made commercially from glucose by using a hydrogenating enzyme, aldose reductase. The manufactured product is used in diabetic soft drinks, jams, chocolate, and sweets. It is only as sweet as sucrose, and it is absorbed from the gut more slowly and converted to fructose in the liver. And therefore, it has less effect on blood glucose levels than sucrose, and that is why it is recommended for diabetic patients. But episodic intakes above 50 grams per day may lead to diarrhea in the diabetic patients consuming these products. Other examples of sugar alcohols are mannitol and dulcitol, and these have a variety of uses in the food industry, especially in the process of fermentation. So basically, that is what we have tonight. Thank you very much.